very popular speaker from UT San Antonio, who's going to give us overall about the AI in radiology and neuroradiology. Please welcome Dr. Achint Singh from UT San Antonio. Dr. Singh did the 4-year fellowship training in neuroradiology, MSK body imaging and pediatric imaging from University of Iowa. And then he moved to UT San Antonio, worked with Dr. Bandit Tantiwongkosi. Currently, he is a director of neuroradiology and also associate director of radiology residency. He won many awards, including Teacher of the Year from for the 2014 and 2016, RSNA Educator Award in 2018, and also UT San Antonio Presidential Award in 2018. Today, he's going to give us an overall about the AI in neuroradiology. This is a very hot topic that radiologists, technologists are concerned. If AI going to replace us, do we going to have a job in the future if we have AI? So please welcome Dr. Singh for to give a talk, and now you can share the screen.
Okay, can you see my screen?
Yes, I can see your screen.
Okay.
Welcome,
Right.
Achint.
Thanks a lot, Tanya, for inviting me. This is a great opportunity for me. I'm Achint Singh. As Tanya mentioned, I'm associate professor, UT Health San Antonio, and I'm a neuroradiologist. And I've been learning about AI for last 2 to 3 years. It's really a great tool for us, and there's a lot of concern out there. Mainly in the students and aspiring radiologists, because they think AI is going to replace us one day. So that's why I've been trying to educate people about AI. I think there's nothing to be scared about, and AI is just any other tool that radiologists can use. So in this talk, I will give a very brief review about AI in radiology. I will touch upon some basics of artificial intelligence, and I don't want to go too deep because I understand some of you may or may not have a background in AI. So just let me know if someone has any question, and I'll try my best to answer that. All right. So with that, let's start. Okay. So this is the outline of my lecture. I will talk about the basic introduction, the history of AI, types of AI in medicine, deep learning, which is a great technique. It's probably going to be very powerful in radiology. If time permits, I can go in a little bit details of the deep learning for image classification. Again, very pertinent for radiologists. AI integration in radiology, the potential benefits of AI integration in imaging, the challenges with AI, and the future or the vision of AI in radiology. Okay, so with that, let's start with the introduction. Okay, so what is artificial intelligence? The simplest definition I could find is it's a task done by a computer which otherwise typically requires human intelligence. So basically, a machine, a computer is doing a task which otherwise requires humans to do that. Okay, so that's very basic definition of AI. How does it work? Humans train the computer by using some rules, and they learn by analyzing the data. Okay, so the important thing here is, as I said, humans train the computer. So at least at this stage, it's the humans who are training the computer by using some rules, and these computers, these programs, they learn by analyzing the data. Okay, so that's the again very basic concept. How does AI work? There are a lot of terms out there which sometimes can be confusing. especially when for us, we do not know a lot about AI and the machine learning and deep learning. So this is a simple image showing the umbrella term. So artificial intelligence is a big group. Okay, everything houses under the artificial intelligence. Then we have machine learning, which is a subgroup of AI, and in the machine learning there is another subgroup known as deep learning. Okay, so that's the overall categorization of the AI. So AI, machine learning, and deep learning. So one question we ask ourselves is how does programmers, they've been programming for a long time, all these engineers, software engineers. So what's the difference now? Why machine learning or AI is picking up, and what's the basic difference? So conventional programming is where you have the rules designed by a programmer. You feed the data to the model, and by going on those predefined rules, you put everything into the model, and then you get the answer. Okay, so that is conventional programming. Now if you flip those answers back there, on the input side, so you have the data, and then we are giving them the answers already. So this is basically what I will call the training phase. Okay, so we are training the model. Okay, so you have the data, and then you already have the answers. Okay, and then you give everything to the machine learning. Now machine is gonna analyze that data, and you already have the answers. Okay, for example, by looking at the CT image, if there's a hemorrhage or not. So you feed the data to the machine, and also you tell them that there is a hemorrhage or not. So machine's gonna look at that. You have to have the big data, so machine's going to look at that, and somehow it's going to try to look into the pattern. Okay, so it's going to try, when it tries to look in those patterns, it's going to try to create those rules. Okay, and once you have a good model, then you can actually test that model out on like a real testing data. Okay, so that is how the prediction work in machine learning. So basically in machine learning, there are no preset rules that the machine knows. Okay, so you give them the answer and you give the data already, and then machine's going to try to create its own rules. Okay, so that's why the data is the key. You have to have a big data for machine learning to work. So that's one basic difference between conventional programming and the machine learning. All right, so after the introduction, let's move on to a little bit about history of artificial intelligence. Okay, especially pertaining to radiology. So 1960s is roughly the time when the first time when the computers were introduced in radiology. In 1970s, we started using CT and digital subtraction and geography. It is at the time when the MRI was introduced. And in 90s, we had the PACS integration. 2000, we got the voice recognition system. Roughly the same time, we also got the CAD in mammography, computer-aided detection. And then since 2000, we've been listening to this artificial intelligence. All right, so roughly this is the timeline of AI in radiology. All right. So we ask this question: why AI is growing in last few years? We learned that it's been around since 2010 and maybe even before that. But why it's growing so fast only in last few years? Is because of two big things. I think one is the data. We have more and more data. We do a lot of imaging, so we acquire a lot of data. And also, I think the other thing is we now have the better computing power. and mainly, due to the gaming industry, they make very powerful GPUs that you can use. So you have to have a very, very powerful computer to run these models on. All right, so GPU as used in the gaming industry is extremely helpful for the AI models. Okay, so the other thing is let's dig into a little bit of history. So one is the Go and the AlphaGo. AlphaGo so Go is this complex board game, in China, and people say that winning this board game requires multiple layers of strategic thinking. That means it's a very, very highly complicated game. And there are a lot of these champions of this game. So AlphaGo is the first computer program to defeat a professional human Go player. Okay, and it's AlphaGo arguably is the strongest Go player in the history. So right now, actually, computer is the strongest Go player in the history. Okay, and so it's not human. So that's one thing where you can see the power of AI. Not too far ago in 2011, we learned that IBM supercomputer Watson beat Jeopardy champions in 2011. Okay, and since then, IBM is trying to integrate into the healthcare industry, especially in radiology. All right, so that's one historical piece. Google started this project in 2012, Artificial Brain Project, which is a network of a lot of computers. And essentially, the data for this computer was just YouTube videos of cats, and the goal was to identify cats. So just after 3 days of training, the accuracy was 75%. Okay, so again, the data, you need to have a lot of data, and then you need to have powerful computers, and you can see the accuracy was pretty good just after 3 days of training. Okay, so since then is picking up a lot. All right. Okay, so moving on to the types of AI in medicine. So if you can just think of two big things, one is the machine learning here, and the other is the deep learning. So machine learning is mainly for like when you wanna work with the tabular data. That means, let's say, no images. Okay, so you only want to look at some numbers and other things. So machine learning models can be used to predict the outcome. You give a lot of data, but again, no images. For example, you can categorize the data on the mammograms, that the lesion looks, are the calcifications or not. You look at the margins, and then you create a big spreadsheet, and then you put all those numbers in, and then the last column is like a prediction, is the tumor malignant or benign, and you feed that data and with the predictions into that model, and then it's going to try to create those rules by analyzing, oh yeah, if the margins are speculated, it's going to be more likely to be malignant. So something like that is an example of machine learning projects. And it can look at the individual features, and it can evaluate those, and then it can figure out if that itself is the biggest feature causing a particular disease. Okay, so that's one subtype of AI in medicine. The other subtype is deep learning. Now, deep learning is something which is very powerful, and it's quite unique to radiology, I would say, because we look at the images every day, right? So radiology, pathology, it's very, very, very interesting to see how deep learning works. So I'll try to spend some time on the deep learning, but deep learning is probably the most fascinating discovery in the AI, which relates to medicine, and in particular to the radiology. So if you want to compare between the traditional, that is a human radiologist interpretation of an image versus AI, okay? So if I'm a radiologist, I'm looking at all these images every day, and based on my prior training, prior knowledge, prior experience, learning from my own mistakes and everything, we think that we probably have become better, and then based on that, everything together, combined together, experience and knowledge and everything, we try to give the diagnostic, and if possible the prognostic information. So that's very typical thing that we do, each one of you do every day. The AI based imaging interpretation is like a loop, okay? So you have to have the data, okay? And so data is housed somewhere in the image library. And this is one area where I think AI still needs help of radiology or radiologist, because AI itself, to begin with, does not know what's in the image, okay? For example, when I talked about the machine learning versus traditional programming, so I said that you have to give them the answers first to train the model, okay? So that's where AI needs the help of radiologists, because they need some sort of ground truth, ground rules that we know based on our training that this image is normal or abnormal, okay? So once we know that, and we give AI those rules, basically, then they train the model, okay? Deep learning, they train the model. And then they sort of do like internal and external validation of the model, which basically is like, did the model predict correctly or not, okay? If there are a lot of mistakes, of course, it's going to have a feedback loop, and it's going to look it again and again and again until it creates a perfect model, okay? So that's one difference, is that the training there's a lot of training involved here, and also it needs a lot of data. And it's kind of similar to what a human radiologist does. We had a lot of training in our medical school, residency, fellowship, and also the data. So AI needs a lot of data. We also need a lot of data. We read a lot of CTs, X-rays every day. So we basically gather all that information, and then like all different images, they have different normal variants. So we know from our own experience that it's normal or not. So with the same idea, the AI interpretation works like that. It's just that the machine is doing everything. All right, so let's move on to deep learning. So like we talked about, deep learning is a subset of machine learning, and it's based on neural network. Okay, I'll touch base on what exactly is a neural network. There are multiple deep or hidden layers. Okay, that's why the name deep learning. And some people also use the word hidden layers. And deep learning models learn the features of the data by themselves, and they optimize the algorithm to get the best result. Okay, so basically, like when we say we made a mistake in radiology report, we try to learn from that mistake so that we do not repeat that. So with the same idea, deep learning models, they try to optimize the algorithm itself by learning from its mistake. But one thing they need a large amount of data. And also, like we talked about, they need very, very high computational power, or a very powerful computer. Okay. Excuse me. So you're going to see this image like that, which is basically a neural network. So on the left side, we have this input layer. Okay. Then there are a lot of these hidden layers. Okay. and then on the right side is the output layer. Okay, so people call this neural network because the idea is that there is some similarity to the neurons in the brain. It's not exactly true, but maybe, like when the neurons fire, it activates the other neurons and all that with all the synapse connections and everything. So that's like a very crude comparison, but it's not exactly similar to the neural network. Okay. And then in the center here is, so we have the input layer and we have the output layer, and then in the middle is all these hidden layers. Okay, and that's where I think deep learning is very, very powerful, because you can have as many hidden layers. Okay, of course you're going to need a very, very powerful computer to do that, especially if you have a lot of hidden layers. Okay. And all these layers, they perform a different type of mathematical calculations. Okay, that we do not have to go into too details of that. So, and these, so there are multiple layers like that, and all these, these round shapes, you can think of those are like nodes, like neurons. Okay. And each of these neurons, they have some information, and they pass that information, like you can see in this cartoon on the right side. They pass that information to the other neurons in the next layer, with the increasing level of complexity. And depending on the type of the data and the type of the problem that it's trying to solve, you may have activation of some neurons and not all of the neurons. Okay, depending on what feature it is picking up when we talk about the image classification. So it's very tough to explain how does deep learning work. I'll try to give you two examples. One is how does a child learn the meaning of the word dog? It's not just child sees that any animal with four legs is a dog, because you can have cats, you can have other animals. It's because child has been exposed to different scenes of dogs, and in their mind they have learn all those rules. They have seen 1,000 images of dogs, and they have learned all those rules without any supervision, right? So that's how they learn how to recognize a dog is. So four legs or a tail is not a great rule, because you can have a dog with only 3 legs, but still a dog. And a child can easily recognize that as a dog. All right, so it's much more complex than that. And that's the same idea, is deep learning just does not see the for example hemorrhage. It sees multiple other things. So it is very fascinating to see how deep learning works. For example, the other example is if you're trying to teach deep learning model that the shape is a square, and then it's going to look at the different parts of the image. This line on this side, this shape, part of the shape on the right side. So each layer is trying to get some information, so that the end result is like it's going to recognize what does a square look like. Okay, so that's the output. Okay, one more example is to understand how does deep learning work is let's say you come back home after work, and you are thinking, should you go for a walk or not? Okay, and let's say there are a lot of these factors which gonna help you decide, should you go for a walk? Is it very sunny outside? Is it very cold outside? Is it raining? Is it night? Are you tired after work? So there are a lot of factors which going to help you decide, should you go for a walk or not. And let's say you are analyzing this this information for a long time. Let's say for 1 year, you've been researching on this and you have the data in the spreadsheet for 1 year. When did you go for a walk? When not? And what are the factors that were helpful? So basically, all these will become your input factors, so on the left side. And then you can feed this data into these different nodes. Okay, so these are nodes, like in the example we saw in that image, different nodes, they get activated. Now inside these nodes is some mathematics working. Okay, again, we do not need to go into too much details. I also do not understand everything about what's happening inside the node, because I'm not a mathematician and I'm also not a programmer. So, but in general, there is some mathematics going on. Which is usually a combination of linear regression, and there are some activation functions. So that's too much detail. But just so that if you can think of a lot of these factors, they are there, which is going to help you decide if you are going for a walk or not. And they are going into these nodes, different nodes. And these nodes are trying to analyze which factor has the highest weightage. That means which factor is the strongest factor, which help you decide if you're going to go for a walk. For example, I can go for a walk if it's a little bit colder, but I will never go for a walk if it's raining. So for example, for me, raining is the biggest factor for me to decide if I want to go for a walk. Okay, so this model will look at that feature from the whole data that you have compiled, and then it will try to give weightage to those individual factors. Okay, so that information is passing through, and then this is your output layer, which is essentially gonna give you the answer. There's something known as loss, and the very basic definition of loss is let's say for the first time when the model predict how far the prediction is from the reality. Okay, was the model like predicted bingo, like to the point, or was the model like far away from the reality? So that is the loss. And the main goal of all these programs in deep learning and the machine learning is to minimize the loss. Okay, so that means your prediction is very close to the reality. Okay, now of course it's not going to learn everything in one shot, right? When it going from the input to the output layer in one pass, it's not going to learn everything, because when it first starts to see the data, it's just a random calculation this model is doing by putting those weights to those individual factors. Okay, so what happens that once you see the outcome after the first pass, and you see the loss, and of course the loss is probably going to be too big because model still does not know, then the programmers they tweak something. Again, the goal is to minimize the loss, and then it kind of goes back, and you kind of update those weights to minimize loss. And again, those weights are those like random numbers that you are putting, that you are multiplying all these factors to try to differentiate which factor has the strongest influence on you when you want to go for a walk or not. Okay, and then after you update that, so this whole process where basically it puts the data back, and then it update the weights to minimize loss. This is known as backward propagation. Okay, that's a very important concept, and I'll try to give you more example, more analogy how to understand this backward propagation. It took me some time to understand this, because we are radiologists. We typically do not think about all these mathematics and everything. What's actually really fascinating when you go deep. So it is doing backward propagation, and then essentially then it's going to run the all that scenario again, which is forward propagation, and again is gonna predict something, and then again you're going to see how big the loss is. So and then again your idea is to minimize the loss, so you're gonna go backward propagation again, you're going to update the weights again. So it's gonna happen again and again and again and again until you get the minimum loss, which means you have the perfect model. Okay, so this training is going on again and again and again, right? So this is I tried my best to teach you how the deep learning works. And sorry if it's too much in detail. Like I said, it is very tough to teach this to people who are not very familiar with the programming and everything and the mathematics. Okay, but I'll give you one more example. Okay, for example, you want to excel in the final test. So what you do is you read a book, but the result is not so good. So how can I do better? Well, I can read more, right? So you're going to read more. So back propagation is a similar concept. So you read more books, not just one book, more books. Result is good, but I think I can do better. So I'm going to do more back propagation. And this time I'm going to read more and more and more. And I got the great result in the practice test. So I'm ready to take the final test now. So I take the final test and, I pass with great results. So that idea of, thinking that you did not do good, you can think of that as a loss. Okay. So like I said, in the deep learning model, your goal is to minimize the loss. And in real life, like in this example, you want to maximize your chances of success in that final test. Okay, so what can you do to better is you can read more, study more and more, and books and different things. So that loop where you go back and read more and more is similar to back propagation. All right. Okay, let me see how we are doing on time. Okay. I'm gonna let's do this. Let's keep going. I'm gonna try to skip this, and if we get time, we can come back to this deep learning for image classification. So let's yeah, let's skip this. I just want to see if we get time, we can come back to that. Okay, so AI integration in radiology. How does it work, and why do we even need AI in imaging? It's because everyone agrees that radiologists make mistakes when they read the studies. It's just human nature. We get tired, working after hours, a long time, and especially a lot of imaging studies are happening every day. So there are a lot of these papers out there, how much radiologists miss. So we all agree, there is no doubt about that. We make mistakes. Okay, no one can argue about that. And I think that's why AI is going to be helpful in imaging. So that's one of the reasons we need AI in imaging. So one solution is integration of AI. Okay. So how can we do that? Now, one thing, like I talked earlier, that you need a lot of data. Okay, so AI is data hungry. But luckily, with all the a lot of imaging we are doing, we do have a lot of data. But again, there is a problem with that data. The ideal data for AI has to be labeled, right? For example, you just cannot pass a CT image to the model thinking that it's going to learn on its own. You have to tell the model that if the image is normal or abnormal, that means you have to label that data, right? And for that, I think radiologists still play a big role in making these models work better, because we label the data. But labeling takes time. Okay, especially when the data is big, you can imagine labeling is going to take a long time. Also the all those exams that we do, different hospitals, they have different protocols, different techniques they use for the CT or for any imaging modality, slice thickness and KVMA and all that for the CTs. So there is no one protocol that everyone's going to use, so exams are different. Okay, so that's one limitation. The report that we put out, it's not structured. Most of the time it is not structured. For example, in my report I might say the findings are suggestive of this tumor, and some other radiologists might say findings are consistent with, so things like that. So that means report is different. It's not a structured report. And computers, they do not like this. They need like a very homogeneous type of report, like is it this or is it not this. So the concept of structured report is very popular now. And there are a lot of programs out there. You put your structured report in, and then they can look at the specific areas of that report, so that they can even extract those words to label the data. Okay, but again, this whole thing with the data is a long, cumbersome, very laborious process. In fact, this is the bottleneck of putting out any AI model. And this is the process which is going to take the longest time. Creating a model mathematically and with the programming, once you do that, it's great. It doesn't take long. But labeling the data and the whole thing with the data curation and everything, pre-processing the data is the bottleneck for the development of any AI model. We also have to think when we are looking at the model, is like, you cannot use the same model for different scenario. For example, if I'm working in the ER and I'm reading a lot of head CTs, I need a model that is very, very sensitive. Okay. So that means it's going to be very, very sensitive. So the true positivity will be very high, which is good. That's what I need. The false positivity is going to be a little bit high, but that's okay. I can look at that image, which is false positive, and then I can clearly say if there's a hemorrhage or not. But the good thing is that if the test is very, very sensitive, it is not going to miss a lot of hemorrhages. So that's the idea with the screening use. But for the diagnostic use, I want a model which is more specific. Okay, because if I put a model which is highly sensitive but not very specific, then there are going to be a lot of false positive, right? So then I'm going to have to look at a lot of those studies, and again, it's going to take a long time and everything. So that is not the ideal model to put in the diagnostic use. So you want more sensitive model for the screening purpose and more specific model for the diagnostic usage. So in general, that's a very crude way of saying how you can balance the system. Okay, so one model not going to work for everything. That means you have to look at different models. And that's what they see this, what is known as confusion matrix, which is essentially like when we learn about some random test, and if there's a disease or not, and then you look at those true positive, false positive, false negative, or true negative. Okay, so that the same table is known as confusion matrix in the deep learning setting. So what are the goals of AI in imaging? Of course, you want better diagnostic accuracy. If somehow it can optimize the work list to prioritize the cases, I have a long list of cases I have to read. Of course, some studies are marked stacked and some are not, but stat studies are not always, life-threatening. Some of the other routine studies may have a, life-threatening hemorrhage or something like that. So if there's a model running in the background of the PACS list, which is looking at these images, and then it is basically prioritizing the cases by giving me a sign that, okay, you should look at this image first, even though this is not stat, but this study is probably, it probably has more stat findings than the other cases. So optimization of the work list to prioritize the cases. And with the same idea, if especially when you're working in the ER, you have a lot of ER cases, the volume is too high, and after some time the fatigue sets in. So if somehow AI model can pre-analyze those cases, and then so that you can look at those first, and also it can screen those cases. Extracting information from images that is not apparent to the naked eye, and that's something is known as radionomics. We do not even know about that, because we cannot see that information. But AI actually, by compiling all those data and all those factors, it can actually give the prognostic information. And the last is if somehow AI can improve the quality of reconstructed images. Okay, so those are not by any means like it's just a complete list. There can be a lot of other things, but in general that's what we need AI to do. Like every other model and everything, to be successful, it has to follow certain rules. Okay, for example, to look at the AI model, if it's going to be successful, you have to have increased diagnostic accuracy. It has to be faster, right? And if somehow it can decrease time and task for radiologists, if it somehow can reduce the cost of healthcare, okay. And in general, if it's great for patients, better outcome for patients, less number of misses, something like that. So those are the things that AI model has to show that it is doing all these things. So moving on to the potential benefits of AI integration in imaging, and some of these are going to be similar to what we already learned. But these are now looking at, let's say you have the model, and then why we think the AI is going to be very, very helpful. Those AI models will be very helpful for your practice. So the first is, like we talked about, prioritizing the cases in the PACS list. Okay, again, it's going to be very helpful. And once you do that, you can have a timely communication. So it's great for patient care. AI actually, you can also have images. So AI can reconstruct some images with some sort of noise, and then you think the study is non-diagnostic or less diagnostic. But also you do not want to radiate the patient again. So sometimes AI can be very helpful in that. And with the same idea, you can have reduced patient callbacks, okay, by improving the reconstruction, and by improving the quality of the images. Increasing efficiency. You can read a lot of cases faster if the AI gives you a hint that this case already has some findings. So efficiency can be increased. And this is something I think eventually in the future we're going to see a lot of that, especially with the radionomics, the pattern recognition, segmentation, and quantification. And eventually the goal could be that if we can prevent or detect disease very, very early on. For example, there was a paper, they showed that you can look at the chest x-ray, and it can tell you when you're going to die. Basically, the model was looking at the, coronary calcifications, the size of the heart, and all those other calcifications. So it can detect the age based on that, if you have a cardiac disease or not, aortic calcifications, degenerative changes in the shoulder joints on the chest. So a lot of factors which when we read the X-ray, we do not think of those, but AI can put together all that data and then basically try to predict the outcome. Okay. So that's what is like beyond diagnosis, so we do diagnosis every day, and somehow I would say we also do prognosis. If I see, for example, a meningioma, I call that a meningioma, and meningioma has better prognosis than GBM, for example. But I would say we cannot do that. We cannot provide prognostic information in all the cases that we read, but AI certainly can do that. Like, for example, I was talking about that example, chest X-ray AI can look at a lot of things to predict the mortality. And on the CTs, AI can look at the cardiac calcification, the types of the calcification, soft tissue versus calcified plaque, coronary calcification, and it can give the prognostic markers, the risk of stroke in next 5 years or something like that, after looking at those calcifications. So those are small things which, as a radiologist, we do not think about that, but AI can dig deeper, and it can go very, very deep. Okay. So radionomics, we touched very briefly. It is basically conversion of digital images into sort of a mineable high dimensional data. Okay, that is essentially radionomics is. So basically it looks at that information that we just cannot see, and then it can look at like we talked about earlier, the calcifications and everything in the CT, the margins of the lesion. So a lot of these things that we do not think and we do not see, but AI model can look at that, and it can compile a big list of those factors, and it can actually provide the prognostic information. Okay. So that, I think, would be the the AI will be very, very helpful in that. Okay, so not everything is hunky-dory with AI, of course. There are a lot of challenges with artificial intelligence. Like we talked about, data mining, data curation, data preparation is the bottleneck of AI models. Okay, and also we need a lot of data. AI needs a lot of data for that. And like we talked about, the data is not homogeneous. Different techniques are used, everywhere. The style of reporting is very different, right? And computer does not like that at all. Okay, so the data has to be homogeneous for that. So that is a big problem. Okay. The other problem is what they call black box. Is like people actually may not know what deep learning model actually sees in the image itself. Okay, so that is known as a black box. And there are a lot of papers out there about that. You see the result of the model, so you think it's going to be really, really good, but it may be not. For example, the model might see that if you give model a chest X-ray of an inpatient and outpatient, and the model might see that the inpatient, they have the worst prognosis. They have more pleural effusion and all the other things like that. So if the model has to predict which patient is going to live longer, is of course it's going to predict outpatient. They are more healthy. They are only there for the screening and all that. But how does the model see? And so there was an interesting example in the literature out there that what the model was actually looking at, so the model result was great, but it turns out that the model was actually looking at is in the inpatient somehow, they put the marker on the chest X-ray, which has some fancy letters and all that, some abbreviations. Sometimes it's the technologist initials and all that. So it was actually looking at that. It somehow predicted that those type of patients, they have a worse prognosis because of those initials, those letters, markers. So nothing to do with the actual chest X-ray itself. So that's what I meant by black box, because you may not see the result itself does not tell you the whole story. But there are a lot of models out there where people actually look at what model is seeing, and they can try to correct that if it's not correct already. Of course, we're gonna have to look at the safety. Like black box is a big thing. What does the model see itself? That's why they have to train model on a lot of data, and then after training, they have to actually feed the model some sort of testing data which model has not seen before, right? So you really have to make sure what model is predicting is safe or not in the real practical world. All right. Privacy again is a big issue, especially when data is out there, and AI, all these big AI companies, they need data. So and people are sharing the data, the hospital, they are sharing the data. So privacy is of course is a big concern. So there has to be some rules about that. Legality is an interesting aspect. Of course, if, for example, if radiologist miss something, a patient can sue the radiologist itself. But if a machine miss something, then who the patient gonna sue? Still the radiologist, the hospital, those engineers, programmers, the company that made the model. So there are a lot of other legality things that we do not know yet. All right. So how does the future look like? So there is no denying in the fact that it is growing rapidly, massively. There's a lot of companies out there who put out their models every day. Okay. It is exponential growth of all these big companies in the AI, and because people know that this is going to change the medicine and radiology for sure. So what we think is going to happen in the future is there will be an integration of AI in imaging for sure, no doubt about that. These AI models will get better and better because we get more data. The data get more is more structured and a better homogeneous data. So the models will get better and better. All these AI startups, AI companies will continue to increase, and gradually universities, hospitals, they're going to have to implement the AI models. And also, especially in the university setup, they're gonna have increased research opportunities with the AI. So what can we do as a radiologist to help help ourselves, help the patients, and help the whole radiology community? The first thing we can do is, instead of getting a shiver whenever we hear the name of AI, is if we try to embrace the AI. Like right now, there's a lot of concern out there that someday AI is going to replace radiologists, and that's why some people do not like to talk about that. They get cold feet. But instead of that, if we just embrace the radiology, for example, it's like when we had the MRI coming up in 80s, and people think, oh, it's everyone gonna see what's going on inside, so they do not need radiologists. but of course did not happen. So you try to embrace the technology and you just try to evolve. So we have to evolve with the AI. So that's my point. So we have to embrace the technology, and we have to understand the core principle of AI. So by that, I do not mean that you have to go and learn coding and mathematics of all those models, but just the big concept, so that when someone is talking about deep learning or machine learning, you have some idea. You do not give them like a blank stare. So you have some idea what they are talking about. So basic core concepts of AI. And training, I would say, we need training, especially at the level of medical students and residency, fellowship. So there has to be some sort of trainings where they can teach about the value, the pitfalls, and the weakness of the AI model. We're trying to implement that for our radiology resident in their lecture curriculum. So give them basic ideas about artificial intelligence. And this is very important because it is going to come for sure. So how can we prepare? We can, like I said, we can provide more education at basic level, starting right from the medical school. Even though this is like a little bit contrary to their career choice, because people can become engineers, programmers, and all that, but they are in the medical school, and they're gonna think, oh, now we have to learn again, programming and everything. But that's, I think that is very, very important. And again, you do not have to learn all the coding and everything, but you just have to learn the core concept of AI. More practical training, if we can create like a work group in the different setting, wherever we work, try to implement some models, and then run it on the real cases and all that, real images. More involvement of radiologists with those projects, of course, under the supervision of someone who has a lot of experience with the AI. And that's where I think at this time there are a lot of companies out there, so they need data, so they're gonna contact you for your data, because you cannot get that data out anywhere else. So you have to contact a hospital or something like that. So these AI companies, they are basically saying that, okay, you give your data, and then we can provide our expertise and all that. We can train your radiologists, we can do some research projects, things like that. So it's like a mutual understanding, how both of those parties they can help each other out. And eventually, I think, especially in the big universities, and it's already happening, that there's going to be AI lab in the big universities. Already happening. ACR, American College of Radiology, has a data science institute out there. So that is already started. So the big question is will AI replace radiologists? And that is very serious question where people ask, especially the students. We have a lot of students who come, and then that's the first question they ask whenever they think that they want to do radiology, but this AI thing is bothering them a lot, because you see a lot of information out there in the news, the TV, that this AI model is much better than the radiologist. So, and some of the information is good, but some of the information is also misleading. You do not know the exact data that the machine was looking at. So will AI replace radiologist? I do not know. I would probably say no to this. Dr. Langlotz at Stanford, he has this very nice phrase. He basically says no to this answer. Will AI replace radiologists? His answer is no. But he also says that radiologists who use AI will replace radiologists who do not use AI. Okay. So that means we have to learn. little bit about AI, and we have to embrace this artificial intelligence. We just cannot ignore that. So I think that's one thing we need to change in our behavior, in our whatever we do every day. We have to learn a little bit about AI. So I think AI is not going to replace radiologists. I think AI and radiologists, they're going to work together to help each other out. And this is, I think, what hopefully it will become, that this AI dash human intelligence model that will help everyone, especially the patients. And that is it.
Thank you so much. Yeah, thank you so much for your lecture, for simplify the one of the most difficult and really sophisticated topic. And
Okay.
I like your analogy about dog. I think that is a very simple analogy that make more sense to me.
Yeah.
You can, a student can identify dog in many way, maybe see the a footprint or a leg or face or something and identify dog. I like that analogy.
Yeah.
Yeah.
Thank you.
Yeah. So one thing that come to my mind, how do you integrate AI stuff, this stuff, to your residency or fellowship training? For your resident and your fellows, how can you give them information, or how can you embed this knowledge for them and make them ready for the future to work with the world, with AI?
Yeah. So I think that has to come, from a high level, like, the chair of the radiology. So the big thing is you have to think about, you have to tackle this problem on three different aspects. One is the commercial. You're trying to buy the software which is going to integrate with the PACS, and with the same company you are trying to negotiate. You can also ask, can we use your expertise to train our trainees? So we are looking at this in three big compartments. So commercial, research, and also educational. We have Dr. Clark as the vice chair of informatics. So he deals with a lot of different companies. So he talks to them, and then so this year we are implementing our lecture schedule, and so we're going to invite them. So that they can lend their expertise. But we also have to make sure, we as a radiologist give some education to the radiology trainees, so that people can talk great about when they are expert in that area. But I think the challenge is to teach something when the audience is not the expert in that area. And that, I think that's why what we are trying to do is, so we're going to give some of the lectures. So they're going to get some lectures from radiologists who are not programmers, who are not software engineers, and they're also going to get lectures from the software engineers who design the models. So that's why hopefully in the whole year that they get like a big picture, like what AI is, what they can do in the future to learn. And I also throw that out, that you do not have to learn coding, but if you have time, and if you can spare some time and energy, I think it's a great thing to learn, especially the Python language. Yeah, it's really good.
Yeah. So how do you integrate this thing with your daily work with your colleagues in the neuroradiology section?
Yeah, right now I would say we do not have that yet. We are still talking, negotiating. But there are these big companies out there. They already have their models and everything, and some university, they are using that, but right now we are not at that stage yet.
I see. So because I feel because to have the successful AI stuff in screening or diagnostic, they need a lot of data, like a very big data, like a million
Yes.
data or something. So which means it's maybe really difficult for the small company to
Yeah.
have that data. So which means like you cannot build in-house AI. You need to collaborate with the company, and that company has to be like a big enough.
Yeah, that is true. But I mean, you can actually make a model, by using your own data. It's just you have to hire like professional people to do that. Data scientists, software engineers, programmers, and all that. But you are right. These big companies, they already have a lot of data. They partner with the hospitals and everyone. But there's a lot of AI startups coming up, and first thing they need is the data. So they like to partner with different universities and all that, and not just universities, are also like smaller clinics. We do a lot of imaging every day, every year. So there is a lot of data out there. So they just have to grasp that. But I agree that to begin with, I think going with the big company is a good idea.
Yeah. So I mean, like I think like for the AI stuff in chest imaging for like screening TB or non-TB, or maybe even like a COVID stuff is very popular right now.
Yes.
But in terms of neurology, I mean like a neuroradiology for us, what do you think is like a top 3 or top 5 questions?
So
like the AI,
I think
like a benefit?
yeah, I think that the number one is going to be the detection of hemorrhage or not on the CT. There was a project that ASNR and RSNA did this year, I was actually part of that project in terms of like labeling the data. So there was a lot of radiologists who labeled the data, and then they have the data, and then they also have the answer which image has a hemorrhage or not, and they put on this website known as Kaggle. So Kaggle is a great website, and mostly for the programmers and data scientists. So there's a lot of data out there, and you can go and then play with the data and then use your model. So basically it's like a computation. So you download the data, and they make the model, they tweak their model, and then they upload that model, and so whoever has the best result, they get a prize. So RSNA did that last year, and their topic was detection of intracranial hemorrhage or not. So I think that will be number one, and that was actually really successful, to detect the hemorrhage, because you can think of like if it's a big hemorrhage, I think it's easy to see, right? The small, thinner subdurals, I think those are tough to see, but a big intraparenchymal hemorrhage is easy to see. So you can think of that. The AI can see that nicely. I think the other thing is detection of diffusion restriction, for the strokes. I think it's going to be a good one I have seen, and detection of midline shift, I have seen that. So I think those, I think it's gonna start with like, what are the things that radiologists need in our long list. We want to prioritize our list so that we can take care of the patients whose findings are like, they're like, they can die from that if we do not report that very fast. So hemorrhage, I think, is the number one.
Yeah, so it mean like something like an emergency, like a hemorrhage or infarct.
Yeah. Yes,
right.
Yeah, I agree.
Yeah, so it's like most of them are like for the screening, not the diagnostic.
Again, screening. Yes, yeah. I think it's going to start with screening, because that's where it's going to have more effect, and people gonna see the advantage. Oh, this is a great AI tool, is it can screen, and then I think gradually is going to go down to diagnostic, because then again they have to tweak the model so that it is more specific for the diagnostic purpose. Yeah.
So this is maybe a silly question. Do you think how long do we have? How much time do we have until like they achieve in that level to prepare ourselves? to be like the mature stage?
This is actually a great question because I do not know the answer to this. I think every day it's they are tweaking their models, and then a lot of research is going on, I don't know. I think it's already there, at least in some of the cases, especially like detection of hemorrhage. I think it's already there. I think so. I think the model is out there. It's just the implementation may not be very widely available yet. Yeah, but I think in next 5 or 10 years, I think we're gonna see AI is growing in radiology.
Yeah. So which means like we still have time to prepare ourselves and also like our young generation radiologists to be ready for like maybe for the next technology, for the AI to be mature and help us.
Yeah. There is no great time to start, today, tomorrow, whenever we get time. I think it's very tough for us because, we already got our training, and everything. So, and, we work every day, we put long hours, and then after hours, you are so tired. I think it is very, very tough. So you need a lot of willpower to do that. But I think we can do this. Radiologists, they are intellectual people, so I think they can do that.
Yes, yeah. So one last question. One of your slides, you're talking about like the process to get the data, and one thing that you mentioned is like about the structural report.
Yes.
So you think like a structural report help with this process more than like like a personalized report?
Yes, it is extremely helpful. There is no question about that. It is extremely helpful, because when your report is like a long paragraph, then the program has to go in different areas to detect something. Versus if you just use the word tumor, yes or no, GBM, yes or no, something like that. And you have all the categories, ventricles, what you see in the ventricles, parenchyma, what you see in the parenchyma. So something like that is very structured so that it gives you the answer. For example, I might say, ventricles are normal in configuration, no mass lesions seen in the ventricle, which basically means I'm saying that ventricles are normal. So if you can have a line like, are ventricles normal? Yes or no? So that, I think it's easier for the program to see that. And RSNA, ASNR, and ACR, they have a great initiative on this. They have a lot of templates out there, so you can try. But I think that is very, very helpful. Yes.
So does it mean like in the process, besides the images that they upload for like to get like the data, they also upload the report and match those two things together to get like information, to like extract the information?
Yes. Yeah. There is certainly program out there that can do that as well. Yeah. So that the radiologist. So that's one way to do that. The other way is like you give radiologist all the images, and then you ask them to label each an individual image.
So you know what? I am not a big fan of the structural report.
But nobody is. Yeah.
So this may be like the way to think if you want to survive in the next, like in this career. And working with the AI, this may be like the way that you should think and start. Like have like the structural report that has like the same format in the like for the hospital, for the section or something. So that's why like you can integrate your work, your daily work list or something for like the AI in the future. Right.
I think that's a great way to start. You can start with your section in neuro. And then try to create some templates. I think that should be the way to go.
Yeah. So which means like for one hospital, when you have like an AI staff, let's say like you hire the company A to do the AI, and you have like your own structural report and everything. And for another hospital, do they need to have like with the same company, do they need to have like the same structural report, or it's like a depend because like those two hospitals gonna combine with the same big data?
Well, so let me ask you this: Are you asking about like when the AI model is still in the training phase, or you are asking about when the model is final and complete?
Both. Yeah, both
So
of them.
when they are still training the data, then I guess yes, the answer will be that yeah, they have to look into the if they do not have the structured report, then they have to label, somebody has to label the data. But if they have the structured report, they can verify the information from that report. But the other scenario is if we are looking at the final product AI model that you are using in a different hospital setting. Um, well, if the model is great, it should work everywhere, no matter the circumstances and everything, because that's what real life is, right? Like, you go to a different hospital, but you do not have to relearn neuroradiology, right? You can still see the images, you can still, see the findings. So the AI also has to do that. I think, and that's why I think is a little bit challenging, because like I said, the protocols are different, the dose, the contrast, timing, is everything is different. But if AI has to mimic radiologists, they have to also overcome that that problem. So it has to be homogeneous, and that's where I think a lot of these big articles, when they talk about 100% accuracy and things like that, I think the one thing they really lack is testing their model in a real life scenario across different hospitals.
Yeah. So let's say like IU hire like a company A for like a hemorrhage, for the AI process for the hemorrhage, and the UT San Antonio also like hire the same company. If this is in the training phase, do IU and the UT San Antonio should have like a same like the standardized template and like a protocol, or it's like a depends, and AI gonna just like a mix and cook stuff?
No, actually,
final product.
Actually, it should not be the same. It should not be the same, because when you are in the training phase, you actually want to train the data so that the data, so you want to train the model so that the model sees different kinds of data. Because in the real world, everything is different, right? You practice in a small setting versus a big setting, so everything is different. So the different type of data, the different protocol is actually better for the models. Now the structure report, yes, I think I can agree that if there is a structure report, I think it's going to be helpful for the model to see what exactly is the image normal or abnormal, and that can potentially, like, you may not need a radiologist to label the image in that sense. But for the data itself, I think it should be heterogeneous data, different data, yeah, for the training. Yeah. But all these big companies, when they negotiate with you, they already have the model. Okay. So actually, I think at this stage, I would say that it's like a commercial stage where they have done the training on a big data, and right now they are selling their products. So they already have like a final version that they are trying to sell. So they are not, most of those, they are not in the training phase now.
I see. Wow, thank you so much for your lectures and answering my questions.
Sure.
So can you give like a final words or like any teaching point to the audience today? Like one thing that you want to know, that you want to let them know, like about the AI. What do you want to tell them, like a radiologist or technologist?
Yeah, I would just say this, if some of the, like a student and aspiring radiologist, if they ask and come to you and ask, will AI replace radiologists? I think we should say that AI probably not going to replace radiologists. It's like we're going to use AI as any other tool. Like we use CT, we use MRI, we use PACS. So those are like tools, we are like soldiers, using all those tools to fight the disease and everything to help the patients. So I think that's what we can say. We just need to reinvent ourselves. How can we learn? Knowledge is never ending thing. So we can just think of AI as like, and is it like a other thing that we have to learn. So we do have to make some changes in our own personality and everything, especially when we think of AI, or is like for the geeks, the nerds, we call those coders and everything. I think it's not like that, because we are not trying to learn the coding from the very basic. That is not the point. But the thing is, if you can just learn some basics of the AI, like what is deep learning, what is machine learning, so that if a vendor comes to you and then they are trying to sell their product and they are talking about all these crazy terminology, you at least have some basic idea. You can ask about their model. You can ask about like, how do you think this model is going to behave in the ER setting versus like a routine outpatient clinic setting? So you have some idea what you are getting into, and I think that would be really great. And I think we do have to do that.
Okay, thank you so much, Dr. Singh, for your excellent talk.
Thank you.
Yeah.
Thank you.
Yeah. So I'm gonna speak in Thai for the audience now.
Okay. Yeah. Thank you so much. It was an honor to come here. Yeah. Thank you.
Okay, thank you ก็ขอบคุณทุกท่านมากนะคะที่มาติดตามเป็นเรื่องที่น่าสนใจมากแล้วก็ทำให้เรารู้ว่าจริงๆเนี่ยเรายังมีเวลานะคะในการที่จะเริ่มเรียนรู้แต่เราก็ต้องเริ่มตั้งแต่วันนี้นะคะแล้วยังไงเขาก็ไม่มีทางมาแทนที่เราได้แน่ๆเพียงแต่ว่าเราต้องใช้เขาให้เป็นเพื่อประโยชน์ของตัวเราเองเพื่อประโยชน์ของคนไข้นะคะแล้วก็เพื่อประโยชน์ในการที่จะทำให้เรามี precision medicine ในการที่จะวินิจฉัยแล้วก็รักษาคนไข้ต่อไปนะคะเหมือนเดิมนะคะหลังจากจบเลคเชอร์ครั้งนี้แล้วนะคะจะได้รับลิงก์ในการประเมินผลนะคะเพื่อรับคะแนน CME ทำการประเมินให้เสร็จเรียบร้อยภายในวันพฤหัสตอนเที่ยงคืนนะคะเพื่อที่วันศุกร์จะได้รับใบเซอร์ติฟิเคตนะคะอาทิตย์หน้าเราหยุดนะคะขอเบรก1 อาทิตย์นะคะมีภารกิจหลายอย่างที่ต้องทำนะคะยังไงก็ขอเบรกนิดนึงเพราะเราทำในเรื่องของ Facebook Live มาเนี่ยประมาณ4 เดือนติดกันละไม่ได้หยุดกันสักอาทิตย์เลยนะคะแล้วก็พอที่ต่อไปเนี่ยค่ะก็คือจะกลับมาในเรื่องของ Imaging of Dementia นะคะในเรื่องทั้งในแง่ของ Clinical Consideration แล้วก็ในเรื่องของเทคนิคนะคะเพราะว่าเรากำลังเข้าสู่สังคมผู้สูงอายุค่ะแล้วก็ผู้สูงอายุปัญหาหนึ่งที่พบบ่อยก็คือในเรื่องของ Dementia นะคะแล้วเดี๋ยวยังไงเนี่ยท่านที่ยังไม่ได้ลงทะเบียนก็ให้ลงทะเบียนมานะคะแล้วก็เดี๋ยวจะได้รับลิงก์ในการประชุมนะคะในอาทิตย์ถัดไปวันศุกร์ค่ะยังไงก็ขอบพระคุณทุกท่านมากๆนะคะแล้วเดี๋ยวไงเจอกันอาทิตย์ถัดไปค่ะสวัสดีค่ะ Thank you so much. Bye bye. Have a good night.